Hi, welcome to Distinti's new science paradigm number 3, the Polytheorism-Disambiguation paradigm. Present scientific thinking exists in what I call a monotheistic paradigm. In other words, believing in only a single theory. And that leads to the false conclusion that we believe we know what it is. And therefore, if we believe we know what it is, we justifiably dismiss any alternatives without question. Okay, but this paradigm, this monotheistic paradigm, is only valid when the final theory is known and physics is done. Okay, friends, the Distinti criteria for humanity being done with physics, this is the Distinti criteria, is when we can cross the entirety of the Milky Way galaxy in 7 Earth days. When we can do that, then I'm pretty much sure I think we know all the secrets to the universe. But until that day comes, we should never assume we're anywhere near than done, and all the theories that we have now should just be looked upon as merely approximations until we can find the counterexamples, and that's covered in all the previous videos to this one. Okay, so practicing monotheism while our footprint in the universe is tiny is ridiculous and will foster stagnation. And let me use the example from one of the previous videos. Okay, if our model or theory that we have is irrefutable, that only means that we have a very small footprint. Like, for example, if we believe in the flat Earth theory, well, if we only exist on a very small part of the planet, it's very easy that we're never going to find a counterexample to that theory. And therefore, the small footprint begets ambiguities. Constraints beget ambiguities. That's one of the rules of acquisitions. But once we expand our footprint, that's when we find the counterexamples to our irrefutable theories. And so we should never assume our theories are irrefutable, it's just we haven't expanded our footprint enough to find the counterexamples. Okay, so again, if we have very few observations, then it behooves us to find as many theories that will fit that data. Like if we only have these 4 points, there's the square, the circle, the star, the triangle, we can find immeasurable amount of theories that fit the observational data without error, irrefutably. And by doing so, we can then say, these theories disagree at this point over here. So I'm going to take a measurement over here. And we even find out that we get a data point over here which says none of the theories that we have is right. And so by finding all of the theories that fit our data now, polytheism, we can drive science faster. So the idea is you find all of the theories that fit your observed data, and then you disambiguate. In other words, you take a measurement somewhere else to find out, which one it truly is. But don't think you're done there. That's just the next step until someone comes up with an even new theory that might still fit all of the observable data. And let me give you a real-world example. When I was searching for the new model induction, which I call new induction, I searched over 45,000 different geometries. And of that search, I came up with 2 others, a spherical field model for magnetism, a longitudinal field model of magnetism. Classical theory had the Biot-Savart model, which is a transverse magnetic field model. Okay, from the vector magnetic potential and VMP, there's 2 different answers that give really good answers to a loop inductor. In other words, a single loop of wire inductance to compute the inductance. You can use the vector magnetic potentials directly applied here, and the answer you get is this for that. Now, if you go into Davis's classical electrodynamics, you have to remove the intrinsic inductance part. That's bogus, that's erroneous. Once you remove that, you get this answer, which is the correct answer, which matches experiment. If you want to see more about this, go to the Foundation series. We go into great detail on this. The other thing you can do is just take 2 loops of wire, where one loop of wire goes through the center, would be at the center of the real loop of wire, and another infinitesimal loop at the edge of the wire, and compute the mutual inductance between the center wire and the wire at the edge. Basically, using a mutual induction approximation, you'll get exactly the same answer. If you apply these to a loop inductor, you get exactly the same answer. Now, here's where most bumbling physicists, and I don't really like being derogatory, but it really shows how poorly trained physicists are. They assume if you get the same model that you basically just re-derived Maxwell's equations. Wrong answer. Wrong answer. The problem here is because all of these four different types of field theory are being constrained to a single type of experiment is the reason why we're getting the same answer. And let me demonstrate that using an analogy. Okay, if I had four very different models of x, or functions of x, if I constrain them to x equal 2, I'm going to get identical answers. That doesn't mean that these model functions of x are identical. It means because of the constraint, I get the same answer. Okay, and so this is how polytheorism will work. If you find all the theory, we use these functions of x as possible theories, and with the observed data we have, if we get all identical answers, irrefutable answers, this is good. This is polytheorism. The next thing we have to do is disambiguate. And these models will tell us where to go. Obviously, we don't want to go sail our starship over to 1 because these two theories give the same answer here. We don't want to go to 0 because all three out of 4 give the same answer here. And so these polytheorism tell us we have to go look at 1 will give us the best, minus 1 will give us the best bang for the buck. That's where all of the different theories diverge. And this is what was done for the new induction. And you can go to the foundation series to see how that was done. And so the paradigm I'm proposing is you find all of the possible models and theories that can fit your observable data. And then from those models, you disambiguate to find the best bang for the buck to go look for the place where they diverge. And that'll tell you which theory is more close to reality. You might even find another point over here that says none of the theories you have is right. And you got to be prepared for that. And that's the beauty of polytheorism. It'll drive you to the best place to find the new place where your footprint is going to expand. As opposed to classical theory, we just sit here at 2 forever and ever and ever and ever and ever until somebody comes up with a counterexample, as opposed to driving to where the counterexamples at the outset. And I just basically covered that. And I came up with an interesting little example of explaining how polytheorism would work. And let's assume that you're on a planet in a distant part of the galaxy or the universe, where there's no visible stars and no moon, and you're the only planet around the sun. So the only thing you have to observe is the sun. Now, because I've constrained the footprint to less observables, guess what happens? That's right, more theories fit the possible explanation of what's going on. You could say, well, the star orbits the planet. You could say both are stationary and the planet spins. Or you could say the planet orbits the star once a day. In other words, a planet just keeps going around the sun. Combination of any of those. And maybe it's a trick of refraction. And you notice how constraining the footprint, no moon and stars, has led to more possible theories that fit the observable data. I don't know how one disambiguates that, but there's a rule of acquisition 21, the speed distance tell, that I thought, which we're going to have a new rule of acquisition 21 video coming out. We're going to use this example to show how the speed distance tell would tell you that the planet spinning is the slowest, least energy explanation, and that's probably the right one, because other than space travel for that example, I really don't know how they would determine, that's a difficult one. That's an interesting problem. So let me demonstrate the polytheorism disambiguation example using Maximals. We're going to go to that demonstration now. This is the demonstration of monotheism and polytheism using Maximals. This is similar to what we did in previous videos, but we're going to show it again in terms of monotheistic and polytheistic thinking. Right now, we can look at this limited data set we have here and say, well, okay, we're thinking in terms of monotheism, where we think we have the answers, we have the right answers, and, for example, the theory of the cow, we have the experiment and the theoretical model which matches the experiment, and because we get excellent answers, it looks exactly the same. that when somebody comes up with another way to explain it, we automatically dismiss those as, oh, we already know what we're doing, you don't know what you're doing, and we go on a happy way, and science stagnates because we think we're done. Also because we're in a monotheistic thing where we think we're done and we think we have the right and the unique and the irrefutable answer and there can't be any others. That's the way monotheists think. And I believe that that monotheist thinking comes from monotheism. We're believing in one God. And we automatically believe all other gods are wrong and bad. And I think that's where this thinking in monotheism comes from. Because if you remember, early science was controlled by the Catholic Church in Europe during the Renaissance. As you know, the story of Galileo. He decided to go against the theory everyone believed, and obviously he was. And therefore, I think that thinking has bled into science, and we need to get away from the monotheistic thinking in one theory. Because this also gives us a problem. It's because we think we know everything that when we do have an anomaly, we ignore it. And we automatically assume, well, that's going to one day be explained within the context of everything else we know, because we know everything. And that's the arrogance that comes from monotheism. Had we been practicing good polytheism, we would automatically say, hey, how wonderful we have an anomaly. Now we have some hope of making some progress. And this would not be sitting here idle. A lot of research and effort would be spent into trying to find if this is the theory, trying to find the physical manifestation. Like this could be dark matter right now. This is dark matter. We have a theory for dark matter, but have no example of dark matter. We haven't seen it. We just have a theory about it because it makes our other things fit. And because of that, this thing about dark matter is just sitting there doing absolutely nothing. We should be looking for dark matter. We should put a lot of effort into finding it or determining that this theory is wrong, one way or the other. Okay, so you can have a theory without a physical manifestation. You can also have a physical manifestation without a theory. And that's what these matchimals are, is like this, and let's concentrate on this guy over here. In this case, this is the physical manifestation, and this is the theory for the cow. And we automatically assume, because they look right, that we're done. But had we been practicing polytheism, other people, we would have come up with all the other theories that match the physical manifestation, the observed cow. This is the observed cow. These are the theories that match cow. And once we have multiple theories that match the experimental data very well, then we're like, hey, how do we disambiguate? And this is going to foster new development, new technology to go, hey, we got to look at these in a different light and say, hey, this is the right theory for cow. Okay, and so it's through polytheism that we're going to drive the footprint and expand science faster. This beholding to one theory fitting our observed phenomenon is ridiculous because we might have the observed phenomenon wrong. We may not be observing the observed phenomenon in enough detail to match the right theory. It could work either way. Okay, we could have the wrong theory for the phenomenon, or we may not be observing the phenomenon with enough detail to get the right theory. And that's why we really need to practice polytheism. Polytheism will tell us that we have more work to go, as opposed to sitting on our bum, okay, with the wrong theory and waiting for our footprint to expand one day later in the future, where we finally, at a much later date, realize we have the wrong theory that fits the physical phenomenon. Okay, so that is the demonstration using matchimals of polytheism and monotheism. Coming back, and let me just reiterate here that the key to science is, for driving science, you have to take all of your anomalies and totally eradicate any anomalies in any theory. That's going to be your best bang for your buck. Okay, waiting for the anomaly to be shown here might take many, many years. That's why if you do polytheism now, okay, you can know, well, we have an ambiguity here, we have to disambiguate. And that'll drive you to the answer that there's a problem here faster if you practice polytheism now. This baloney where we sit on one theory for one set of observational data and disregard any possible radical differences to that, that's complete and utter irresponsibility among science. Okay, so a conclusion. Polytheorizing and disambiguating will drive science down to a single theory that explains everything. Thus, ironically, the end result is monotheism. But again, you have to use the Distinti criteria or some criteria to say when that day has occurred. But thinking prematurely in terms of monotheism is like spending your first week's paycheck before you even know if you've been accepted to a new job. Or counting your chickens before they're hatched. It's arrogant, it's foolish, it's counterproductive, and it's stagnant. And my opinion is polytheism should be practiced long after we believe we have the ultimate truth. Just to be absolutely sure we haven't been lulled into a false sense of being done. Thank you. Thank you for your support. Please get the word out about these videos. I know they're not the best videos in the world, but I do believe that they're our best hope for advancing science. And if you could donate on my website, there's a donate button and with a PayPal thing. I'd really appreciate that. Thank you very much.